name Dubai comes from an Arabic word meaning young locust. And according to some, this was a region where the locusts laid their eggs. But nowadays, the buzzing of the locust has given way to the hubbub of trade and commerce, thanks to the foresight of Dubai's dynamic ruler, His Highness Sheikh Rashid bin Saeed Al Maktoum. For local craft, the natural creek provided water. But for the large and for foreign goods, it proved itself inadequate. Port Rashid, the 15-berth deep-water harbour built between 1968 and 1972, catered for that need. And it's presently being expanded with a further 22 berths to meet the demands of the shrewd businessmen of Dubai. Industrial development was His Highness's next goal, and in order to draw this development away from domestic areas, the envisaged industrialization had to be located around the new port of Jebel Ali. The new port is located 40 kilometers southeast of Dubai, along a deserted stretch of beach where the ships of the desert will be replaced by the ships of the sea. The discussions resulted on the 2nd of August 1976 in the official signing of contracts, whereby His Highness the ruler awarded to the Meenah Jebel Ali Construction Company the civil engineering works, and to Gulf Cobbler Private Limited the dredging of approximately 110 million cubic meters. Chairman Mr. Ahmed Bakr and Director Tom van Houstay signed on behalf of Gulf Cobbler. Sheikh Hamdan, on behalf of the ruler, announced the project to the assembled international press.
في إنشاء ميناء جبل علي الذي هو سيكون من أكبر المواني في المنطقة. طاقة الميناء 74 موقع. يعتمد على اللي هو 15 موقع للصناعية، 15 موقع إلى اللي هو المواد المارة اللي هو ترانزيت، و20 25 للأغراض الصناعية.
To celebrate the winning of this contract, Dubai Transport Company's chairman, Mr. Ahmed Bakr, and Mrs. Bakr entertained local officials and businessmen from Dubai and members and directors of MJAC and Cobbler. As announced by Sheikh Hamdan, the new port would consist of 74 berths, catering for bulk carriers, general cargo vessels, container shipment, and tanker berth. Being located inland, the port required an approach channel 60 meters in depth and extending some 17 kilometers out to sea. The harbour had to be dredged to 14 meters for the seaward leg and to 11.5 meters for the inland leg. A total of 15 kilometers of berth had to be constructed. The site preparations well and truly on the way, the scheme was officially inaugurated the same day by His Highness Sheikh Saeed bin Sultan Al Nahyan, ruler of Abu Dhabi and President of the United Arab Emirates, by starting the pile driver thrusting home the first sheet pile. The rulers of the other UAE member states also attended the ceremony. The official part over, business now starts on the real work. Detailed planning for the first phase is now required, and the engineering skill of the contractors put to use. Work began officially on the 21st of June 1976 with the cutter suction dredger Dubai Bay dredging its way in from the sea, whilst a section of the coastal dunes was removed by trucks and scrapers. When a suitable protected area had been created, the dredger Port Harcourt was brought in to remove the harder materials encountered inland. Dredged material was first piled on the beach, but as soon as the dredger had worked itself sufficiently inland, reclamation of low-lying areas was started, enabling the civil contractor to prepare for construction of the quay. Gulf Cobbler had undertaken to complete the dredging of the 110 million cubic meters within 5.5 years. And in order to meet this objective, plant with a large capacity suitable for this work had to be designed and built. On the 28th of September 1976, a contract was signed with IHC Holland for the building of 2 cutter suction dredgers with 2,000 horsepower on the cutter, and with Shipyard Van Race for 1 booster station to work in conjunction with one of the dredgers. This order was doubled on the 22nd of December 1976. A cutter suction dredger with 750 cutter horsepower was also ordered with Shipyard Van Race.
Ik doop u daarbij en ik wens u behouden vaart.
On the 10th of December 1976, Mrs. van der Hoof christened Dera Bay, which was shipped to Dubai mid-December aboard the Maria Smits, commencing its task on site on the 19th of January 1977. On the 5th of May 1977, Mrs. Sarina Bakker, wife of Mr. Ahmed Bakker, chairman of the board of directors of Gulf Cobbler, launched the first of the 4 heavy-duty cutter suction dredgers and named her Jebel Ali Bey.
I christen you Jebel Ali Bey. May you have a successful, long, and happy life. God bless you.
No, take over.
On the 6th of May 1977, Mrs. Judy Lowry named and launched the Jumeirah Bay.
I christen you Jumeirah Bay and wish good luck to you and all who sail and work with you.
On the 22nd of July, Mrs. Anita Saleh, wife of Mr. Abdullah Saleh, one of the directors of Gulf Cobbler, named and launched the Maktoum Bay.
Rahim. In the name of God, I christen you Maktoum Bay. God bless you and those who works on you.
Glorious return.
dredger Zabil Bey and wish her long and successful service. God bless her.
The last of the series was named and launched by Mrs. Mary Hutchinson on the 7th of September. After extensive tests of the Jebel Ali Bey, involving also a 3-week dredging trial, the first 2 vessels were handed over to the owners and, together with auxiliary equipment built with other yards in Holland, were loaded on board the Giant II and left at the beginning of September, heading for the sun. For the dredging of the approach channel in unprotected waters and unpredictable weather conditions, more reliable equipment was needed than the weather-prone conventional cutter suction dredgers. The revolutionary and daring decision to design and construct the first self-elevating cutter suction dredger, named by Mrs. Nell van Huyste on the 22nd of June 1978 in Hiroshima, Japan, could be a new era in the dredging industry. This sophisticated vessel, crammed with electronic devices, will work in conjunction with 3 split hopper barges of 1,250 cubic meters each. These barges, built by A. Falk & Sons, are fitted out with Kongsberg dynamic positioning systems, enabling location keeping unattached to the dredger. Being fully classed for sea voyages, they sail to Dubai under their own steam. The works, with all equipment on site, progressed as planned, and sections of completed areas, together with quay walls, were handed over in time. To meet those schedules, the inner harbour excavation was divided into 2 sections. The seaward leg, with entrance channel, to be dredged and the excavated material to be used to reclaim surrounding low-lying land and an offshore area, and the inner leg, on a subcontract basis, to be excavated in the dry and the material used to raise levels of a large inland area. The total, 53 million cubic meters, to be dredged consisted of 20% sand, 30% sandstone, and 50% breccia of various degrees of hardness. Most of the sand was to be stockpiled for use of backfilling behind quay walls, and also the sandstone was partly stockpiled for use of road-based construction. The breccia was mainly placed in the offshore reclamation area. The vastly different types of material to be dredged required different dredging techniques, and particularly for the breccia transportation, optimum performance of the main dredge pump engines was required. To maintain a high performance, particularly the cutter with its changeable cutter teeth had to be kept in good condition, sometimes requiring 10 cutter teeth changes a day. The dredged material is then pumped through pipelines, sometimes aided by booster stations, to reach the maximum 5 kilometers delivery length towards the disposal grounds. Here, the uninterrupted dredging process is achieved by disposing through a number of branch lines, at the same time spreading the material over larger areas. With pumping, the high abrasive material wear on the equipment and pipes is high, and a measurement team is recording the wear process continuously, enabling optimal use of pipes. Cutters are also under constant repair. To cope with all the repair and constructional work, a well-equipped workshop has been established. After an uneventful trip from Japan, the Al Wasl Bey arrived on site and was immediately put to work in the approach channel. The vessel is equipped with 4 pairs of legs, each pair consisting of a movable leg mounted in a carriage and a fixed leg. The raising and lowering of these legs is done hydraulically through a rack and pinion system. The dredged material is disposed of through chutes mounted on the aft pontoon, loading the self-propelled barges. The ladder, positioned between the 2 pontoons and hinged to the aft pontoon, swings through an arc from port to starboard by means of side wires connected to anchors. These anchors were also specially designed to enable them to be replaced even in adverse weather conditions. They each consist of 3 tubular 24-meter-long hollow columns connected together at the bottom. By filling the columns with water, the anchor is settled on the seabed, after which the desired strain can be applied to the side wire. Clearly, forward movement of the dredger necessitates repositioning of the anchors from time to time, and this can be done by pumping out sufficient water to raise the anchor from the seabed, and once repositioned, to refill it again. For all personnel employed on the project, accommodation had to be built. Married expatriates of the consultant, of the civil contractor, and of the dredging contractor were housed in Meenah Jebel Ali village, comprising of 300 bungalows, a swimming pool, clubs, sporting and medical facilities. Moreover, since most of the personnel will be here for the duration of the contract, they've turned their houses into positive homes. One of the most important facilities provided was a Dutch-English school, catering for the full range of elementary level education.
Ja, lekker zo. Daar heb ik wel toe. Trouwens, ik hoor dat het bijzonder slecht is buiten. Dat die jongens die aan boord gegaan zijn van het eiland, die kunnen er niet af.
Oké. Hier is te drinken voor jullie, ja?
Heerlijk.
Zo. Sascha drinken. Daar.
Ja, kom hier. Ga even kijken. Laat eens even kijken. Wat heb je erin? Laat eens kijken. Doe eens open.
Waar staat er open?
Ja, zeg niet. Zeg niet. Ja, mooi zo. Laat eens kijken. Laat eens kijken. Haal het er eens uit.
Alsjeblieft. Mooi.
For young and old alike, however, few pastimes here are more popular than windsurfing and sailing. For those who've come out here without families, there's the beach camp, with its first-class kitchen and well-stocked bar.
You say yes? Yeah, otherwise, I think yes. 1, 2, 3. That's first, that's second. You want? Ja, zeg ik. Ik heb zelf eens wat oude vragen op mijn slot zien. Ik kan het ook niet.
Many of the steps towards the successful outcome of this project have already been taken. But, though we may have earned a moment's rest, we cannot afford to be too complacent. So, let us gather all our strength, for tomorrow is another day.
Jebel Ali, 67 berths where none had been before, surrounded on all sides by a vast industrial complex of refineries, smelters and factories. It done? Who made the sea flow into the desert to make an instant harbour at the heart of a multi-million-dollar complex? It was the vision of one man, the ruler of Dubai and vice president of the United Arab Emirates, Sheikh Rashid bin Said Al Maktoum, coupled with the expertise and energy of two joint venture companies, Gulf Cobbler and Meenah Jebel Ali Construction, soon to become known and respected as MJAC. These are the companies who made the ruler's vision a reality and performed a construction feat that has echoed around the world. The vast project was set in motion when His Highness, with the Crown Prince and Finance Minister, in 1976, signed construction agreements with the Arabian, British and Dutch partners who together formed Gulf Cobbler and MJAC. In June the same year, the first dredgers ate their way through the beach from the open sea to begin their share of removing 120 million cubic meters of seabed and desert. At the inauguration ceremony, Sheikh Rashid was able to show the President of the United Arab Emirates, Sheikh Zayed bin Sultan Al Nahyan, the birth of a project that would add a new dimension to the future prosperity of their country. Within a few months of the signing, the sandhills were littered with millions of dollars worth of plant and equipment. The construction of one of the largest man-made ports in the world had started. From hastily built huts on the sand dunes, the consulting engineers began the preparation of the thousands of drawings that would create 2 great basins with 10 quays and extensive cargo facilities. They divided the work into 2 stages. Stage 1 was to dredge out the entrance channel and entrance basin to -8 meters, build 3 kilometers of sea wall out into the Gulf, build another 3 kilometers of sea wall to contain the reclamation area, complete 5 wharves in 18 months ready to receive ships, select an economic design for the remainder of the wharves, and have a second stage, the progressive release of all the berths within 4 years, well underway. The Wallingford Research Station in England built a model of the harbour to find the best alignment for the approach channel and sea walls to give maximum protection from waves to both ships and harbour. A total length of 5.5 kilometres of seawall was called for, made from 4 million tons of rock, armoured with 30,000 stay-bits. As the nearest quarry was 35 kilometres away, a continuous stream of trucks were mobilized to deliver the 75,000 tons of rock a week necessary to keep Sheikh Rashid's schedule. The first wharves had to have a dredge depth of 5.5 meters. To make use of plant and materials readily available, they were designed with sheet pilings tied back to an anchor wall. Construction could thus start immediately, while more ideal designs were found for the quay walls of the 2 great basins, whose dredge depths were 11.5 meters in one and 14.5 in the other. Unfortunately, early tests revealed a hard substratum that prevented conventional piles from being driven to more than 13 meters. This problem, and the worldwide shortage of construction materials, led to an unconventional engineering solution. A design that used available tubular steel piles joined together by slotted tubes welded along their sides to make an interlocking clutch. To give their ends a firm grip, the tubes were vibrated into slightly smaller holes for the last 5 meters. A capping beam was then cast over the top. This unique solution meant the first quays would be ready to receive ships in 18 months, on schedule. As the project got underway, a new village was built to house the army of workers and expatriate staff. 300 homes with schools, clinic, sports facilities, and all the essentials of a modern community where none had been before. A major project by any standard. But within 6 months, families were moving in. In order to cope with the hard substratum and the client's schedule, 4 large suction dredgers had been specially ordered from Holland, each with the massive strength of 2,000 cutter horsepower. With the arrival of the heavy-duty dredgers at Jebel Ali, dredging stepped up to a rate that made the schedule a certainty. As Jebel Ali lay on a wide, shallow shore, an approach channel had to be dredged 20 kilometers out into the Gulf to provide a safe entrance. A laser beam location system was used to keep the dredgers in position 24 hours a day. By July 1977, the entrance wharf had been completed and materials began to arrive by sea, just 12 months after Sheikh Rashid had signed the contract. With the first 5 berths well underway, there remained the construction of the quay walls surrounding the 2 great basins. 13 designs were considered with their many advantages and disadvantages. Experience finally pointed to a design dating back to Roman times. Mass blockwork, a design that had the great advantage of taking the concrete work out of the deep trenches onto a production line. This allowed seawater to be used for mixing concrete, a vital consideration in an area where fresh water is scarce. To make and lay the staggering total of 65,000 45-ton blocks, MJAC built the largest precasting plant in the world. A sophisticated 2-kilometer production line that applied the latest technology to an ancient design and reached the astonishing peak of 168 blocks a day. To maintain such a rate for 2 years, cement was needed at the rate of 1,000 tons a day. And 40 trucks had to work day and night, 7 days a week, hauling 6,000 tons of aggregate 130 kilometers from the quarries in the Hatter Mountains. Block walls, the contractors faced their biggest problem, the groundwater. Could they lower its natural level of only a meter beneath the surface to 15 meters, so the walls could be built in dry ditches? Trials were carried out with extensive well pointing around the site to try pumping it out. It was a bold experiment that paid off. Within a few weeks, the groundwater had gone down to 15 meters, enabling the contractors to make a risk assessment that would decide the engineering of the entire project. If they built entirely in the wet, the client's schedule was impossible. Partly in the dry would make it possible, but could lead to financial disaster. If the groundwater got out of control, it would flood plants worth millions of dollars. they decided to build in the dry. The decision to build in the dry not only favoured block wall construction, it meant also that the expensive deployment of numerous dredgers to take out the entire 90 million cubic feet of sand and rock to form both basins could be avoided, and one of them could be formed by dry excavation instead. The main road through the Emirates was raised over a 4-lane culvert to give the dump trucks a quick, uninterrupted run to the surrounding reclamation area. By the end of 1977, the completion of Stage 1 was in sight, 4 months ahead of schedule. The contractors had responded to a discerning client and were achieving staggering results. In February 1978, the Jebel Ali sand dunes of 18 months ago welcomed the first ship into Jebel Ali Harbour. The second stage was to make further quays available to shipping while construction continued on the remainder of the harbour. An exercise in logistics to keep all aspects in phase: wet dredging, dry excavation, and quay wall construction, so that all carried on simultaneously while the harbour became progressively more operational. The next quay sections that were to receive ships were isolated by building temporary dams across the completed walls and trenches. They could then be flooded up to sea level, their protective bunds removed, and the quays opened up for shipping. Isolating the completed quays with water stops meant that excavating and block laying could continue on the dry side without interruption. Wet dredging to form the remainder of the outer basin could continue nearby quite independently. The section of Quay 1 to be opened up for shipping early in the second stage has been especially built and equipped to handle bulk carriers bringing aluminium ore for the new smelter in the nearby industrial complex. The section of Quay 3 to be opened up was to be a major container terminal with sophisticated equipment for the rapid handling of containers from around the world. Early in 1979, Gulf Cobbler brought out to the Gulf the Al-Wasl, a new concept in the dredging world, especially built for this project. A self-elevating cutter suction dredger that actually walked on the seabed. a computerized monster that sat above the waves with a dynamic positioning system to lock barges beneath its discharge 24 hours a day without fear of tide or weather. Special dumping grounds for the spoil were located as a result of extensive surveys by biologists to minimize any adverse effects on marine life. With the Al vessel dredging out the entrance channel and all aspects working in phase, it was clear that Sheikh Rashid's 5-year schedule would not only be achieved, it would be better. Jebel Ali looked set to become a construction feat unparalleled in peacetime. Technical experts and heads of state came to look. In June 1979, the first container ship sailed into Jebel Ali to bring another key into service and raise the number of ships now visiting the harbour from 20 to 70 a month, while half the harbour was still being built. As the completed section of the inner basin couldn't be filled by simply removing the protective dam, the resulting flood would have been disastrous. It had to be filled by siphon and pump. The dam, protecting it from the open sea, could then be removed. With the harbour moving rapidly to completion, so was the surrounding industrial complex. Each unit in the complex is integrated so that any waste material or energy from one is used by others. Waste chemicals from petroleum products are recycled to the aluminium smelter. Waste heat from the smelter drives the water desalination plant, and so on. And nearby, an international hotel rose on the foreshore. With the completion of the block wall quays around the outer basin, their construction trenches were also flooded up to sea level. The dredgers then removed the island left in the center of the outer basin to bring their share of spoil removed from the desert to 60 million cubic meters in less than 4 years. On the west side of the entrance channel, a 50-metre-high harbour control tower was built with a commanding view of the entrance and harbour. Before the end of 1979, only one major task remained: the completion of the 3.4-kilometre Quay 7. While the dewatering plant kept pumping out the continuously encroaching groundwater and discharging it into the channel, the completed quay walls saw the giant excavators scoop out the last of their 30 million cubic metre share of sand and rock. The building of Jebel Ali would soon be over. The financial risks and massive mobilization of men and materials only a memory. In April 1980, only 3.5 years since the first dredger ate her way through the beach, the last of the dry, excavated basins was ready to be flooded. The filling of the inner basin was carried out quickly by the same pump and siphon method as before. There only remained the removal of the protective dam. MJack and Gulf Cobbler had excavated 120 million cubic metres of seabed and desert to let the sea flow in and make one of the great harbours of the world, surrounded by a vast industrial complex. The great project was completed. Sheikh Rashid's vision of a new harbour surrounded by new industries is now a reality. For 4 years, MJack and Gulf Cobbler, using the most advanced techniques, kept all work in phase, so that weeks saved the first year became months the next, until the sand dunes of Jebel Ali saw one of the largest man-made ports ever built, completed in record time.